So, you want to save the world with clean energy? Make money doing it? Confused about the economic and technical realities of residential and commercial solar, batteries, heat pumps, EVs? Want the real-world scoop on new energy technologies, not manufacturer hype? Then tune in to the Weekly Energy Show, hosted by Barry Cinnamon. Insights from Barry's 40-plus years in the solar and energy industry will help you understand the future ways we'll generate and consume energy. And now, here's Barry.
Welcome to this week's Energy Show. Now, technology that we use to fuel our society continues to change and evolve. I mean, I'm just kind of going through the transitions from wood fires to coal to oil to nuclear in the 50s to natural gas, which is powering most of our electricity now, and to wind and solar, and who knows what's going to be next. What's interesting is that over 60% of the utility electricity capacity last year in 2016 was generated by wind and solar. So that most of the new capacity, the new systems are going in by far, are utility scale wind and solar plants. And that's not even including the distributed generation rooftop business, which is also probably adding another 10 or 20%. So you look at what the economy, society is doing to generate more electricity. Utilities are putting in wind and solar. Businesses and homeowners are putting in wind and solar. And these changes in technology are driven by economics, by cost improvements. Now, the utilities select the technology they're going to use to generate electricity based on whatever increases their profits the most. And that's just kind of the way it is. So they don't necessarily look at producing power using the lowest cost generating capacity. They don't look at producing power using the cleanest generating capacity. They don't necessarily look at what's most reliable. All those dimensions are kind of required by the PUC. It's what they're supposed to do. They basically will select the technology that gives them the best profits. And right now, they're kind of the preference has been for natural gas and also to a very large degree, wind and solar. They like to build those plants. Now, they also don't like for people to put them on the roof because then they don't get those profits. But they're moving towards wind and solar. So the wind and solar and natural gas are the winners in that battle, and it's very, very clear. And the losers are coal and nuclear power plants. These old plants are being decommissioned. Now, there are a few nuclear plants that are still being constructed. Actually, I think they're down to one. And I'm not sure about other coal plants that are on the drawing board, but they're probably not going to happen. And actually what's happening is these coal plants are being decommissioned and removed, and the nuclear plants are being shut down and decommissioned. Very expensive process. Obviously, the coal and the nuclear industries, these big industries, the nuclear's been around for 60 years and coal's been around for 100. They're really upset, and they're lobbying intensively to improve their business, to make sure that utilities still want to use their power plants. And so it's a big battle, and there's an impact that's happened just recently. So first of all, in terms of setting the stage for this, let's look at the recent Department of Energy study on grid reliability. Now, we did a show about that a month or so ago. I'm just going to summarize it really quickly. Department of Energy Secretary Perry wanted the study to justify the Trump administration's passion for coal and nuclear power. They're big fans of coal. They want to put coal miners back to work. They like nuclear. So they wanted to do a study on grid reliability that showed that coal and nuclear are good for grid reliability. This study completely avoided any discussions of climate change, of costs, of renewable energy, of new technologies. And actually the goal, and this is something that was disclosed, is the DOE, Perry, wanted to blame the coal industry's problems on climate change regulations and on renewables and regulatory burdens. So what's interesting, when the study came out, it was pretty clear, we all know this, is the problem with coal and nuclear, and the reason why it's not cost effective, is because natural gas is so cheap. So utilities want to put in a power plant. Why should they spend 20 years putting in a nuclear plant or 5 years putting in a coal plant that's going to be polluting when they could put in a natural gas plant much faster, and it's going to be cleaner and it's going to operate more cheaply? So they're not doing it. So and that's what this study concluded, that coal and nuclear were expensive compared to natural gas. It wasn't that coal and nuclear are suffering because of renewables. So that kind of left the nuclear and the coal industry saying, hey, heck, what do we do? How can we kind of keep our businesses humming? Well, when the basic economics fail of your product, then they can come up with a new economic argument. And the argument was that we need utilities need coal and nuclear plants in case of disasters and emergencies, because theoretically these plants would be able to generate power in a much more sustainable long-term way. So the DOE's argument was that coal and nuclear would make our grid more reliable. So Energy Secretary Rick Perry asked the Federal Energy Regulatory Commission, or FERC, F-E-R-C, let's just call it FERC, to create a new rule. This is a new power plant rule for utilities to ensure that certain reliability and resilience attributes of electrical generation resources are fully valued. In other words, they want to create new incentives for coal and nuclear power. Specifically, the DOE said that there was a need for new pricing methods for power to deal with the premature retirements of power plants that can withstand major fuel disruptions caused by natural or man-made disasters, and during these critical times, continue to provide electric energy, capacity, and essential grid reliability services. So this proposed rule would allow for the recovery of costs of fuel-secure generation units. So they're actually saying coal and nuclear are fuel-secure generation units with specific features such as a 90-day fuel supply on site in the event of supply disruptions. And, you kind of look at this, and these regulations are going to apply only to coal and nuclear power, because natural gas is distributed through pipelines, and obviously there is no fuel for solar or wind, and obviously there's no fuel for solar and wind. So this is kind of a set of rules that are rigged to make coal and nuclear more attractive again. Now, keep in mind that these efforts are 100% politically motivated. Now, coming from the Secretary of the Department of Energy, Rick Perry, they're not coming from the staff at the DOE. So just kind of a little bit of background. The way these federal agencies work is there's thousands of really dedicated, hardworking people. That some of them have been there for a long time, very smart people, very passionate about their business. They're employees of the federal government. They do what the federal government wants them to do. Now, the dilemma, the trick, the way our system is operated is every one of these agencies has a political appointee, the secretary of, in this case, the Secretary of Energy, who is appointed by the president that kind of follows what the president wants to do. And we got the same situation in these other agencies. I mean, just talk about the Environmental Protection Agency, the EPA Secretary Scott Pruitt, and he's been appointed by Trump. He's doing everything he can, everything humanly possible to eliminate environmental regulations, which is just like totally ass backwards. All right, so I have two big problems with these new rules and this approach. First, coal and nuclear are expensive, they're dirty, and they're old-fashioned generating technologies. They're not nearly as cheap as natural gas, wind, and solar. And second, this is amazing. Large central generating power plants do not improve grid reliability, and we'll talk about that more in a minute. But in fact, these plants are contributing factors to an unreliable, less resilient grid. Just ask anyone who suffered through a recent blackout. I can't even think of a situation recently in the whole United States where there was a blackout that was caused because a central generating power plant shut down. It's always about something else. We'll talk about those in a minute. It's much better to have thousands of interconnected solar, wind, and battery storage plants supported by small natural gas plants. And that's actually what we're doing in California, putting in lots of smaller natural gas generating plants. And then there's lots and lots of distributed generation, solar, wind, and battery systems. And some of these are run by utilities too, but they're very reliable and they're very distributed. All right, here's an analogy about what's happening with the DOE and DOE's rules that they want FERC to put in place. Let's say 100 years ago, the horse and buggy industry went to war against Henry Ford. They kind of realized, hey, gee, this car thing looks like it's really going to, be a winner. What are we going to do about our horse and buggy industry? So the horse and buggy industry claims that there's an emergency shortage of gasoline. And if there's not enough gasoline, it's going to shut down the U.S. transportation system. So what should we do? Well, horse and buggies are the only reliable vehicle when there's no gas. So we have to kind of have some kind of remedy that's going to subsidize the horse and buggy industry because they're getting clobbered by the car industry with free horse feed and stables. So let's make the horse feed and the stables free or much cheaper for the horse and buggy industry. So it's going to be more cost effective to have horses and buggies instead of cars. And so the result would be a tremendous setback in the car industry. It's the same thing that the DOE is proposing to do with the new energy industry. They want to subsidize coal and nuclear power plants so that utilities want to build more of these plants. Because basically right now, utilities say, we don't want these plants. They're not cost effective. And the ones with a conscience also say, gee, they're dirty and they're doomed and there's better technology. But when the money talks. So the result is going to be more expensive power because these subsidies are going to have to be paid by ratepayers. The result is going to be, obviously, more pollution and less grid reliability because we're not putting in the systems that are going to make a reliable grid. And the U.S. is going to fall further and further behind when it comes to a grid technology standpoint. Okay, so what does this new FERC rule mean for grid reliability? Well, I kind of look at it and say, gee, let's take a look at some examples, some recent examples of the failures of the grid, of blackouts that we've had in the United States. It's kind of the same thing that's going on in the rest of the world. So, all right, the biggest one that I can remember is the Northeast blackout of 2013. Now, I also remember when I was a little kid, there was a big blackout in New York in 1965, but let's just look at the one that was in the Northeast in 2003. So far, that was the biggest power outage, the biggest blackout we've had so far in the United States. There was a widespread power outage that occurred through pretty much most of the northeastern and the midwestern United States and the Canadian province of Ontario. On Thursday, August 14th, middle of the summer, just after 4 o'clock p.m., there was a programming error or some kind of bug in the alarm system at the control room of a major power plant, First Energy Corporation. And the operator saw this bug and they said, oh, we need to move power flows around a little bit and redistribute the power. And they did it the wrong way. And what ended up happening is there was a cascading effect that more than 500 generating units, natural gas, coal, nuclear, and 265 power plants shut down during this outage. And the reason is that they thought there was a power failure, there was an outage, and these power plants didn't want to continue to be producing power if there was no way to send the power out. So the plants automatically shut down. It was a cascading effect. Boom, 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 boom. 265 power plants just shut down. All of the coal plants and all of the nuclear plants also shut down during this blackout. And the thing is, if somebody wanted to run one power plant, you just can't do that because one power plant can't feed the entire grid. These things are all interconnected. So if there's an outage and you want to run one power plant, you kind of have to isolate that one grid. They're either all working or none of them are working. At least that's the way the systems were designed back then. So huge blackout, huge problem. Power plants, there wasn't a problem with coal or nuclear or natural gas. It was just a bug in the software that shut the thing down. That can happen again. All right. Now let's look at something more recent. The recent disasters in Houston and Florida. They had big hurricanes in Houston, big hurricanes in Florida. Widespread destruction of the transmission lines. So the wires between the power plants and the homes were all knocked out, as well as all the local distribution systems. So the power plants themselves in the Houston area and a lot of Florida, they weren't destroyed. They were still able to run, but they had to shut down because there was no place for their electricity to go. And there was probably not enough people to maintain them, and they really couldn't operate it efficiently when there was some damage. So 25 million people in Florida lost power. I'm not sure exactly how many in Texas, but a lot of people in Florida lost power. The coal and the nuclear plants that were there, they shut down too because there was no place for the power to go. It couldn't be sent to the customers. So also the centralized natural gas and the utility scale solar and wind plants, they shut down too. And probably some of the solar power plants and the wind turbines, if they were there, I'm sure they probably, really, really big wind and probably knock them over. But guess what? The people in Texas and Florida that had rooftop solar and battery backup systems and generators, they still had power. You kind of think about it, solar and batteries are better because they're going to keep working even if there's no fuel. The generators, if you're out of power for like a week, usually people might have, a few days worth of generating fuel, gasoline or diesel, or if there's natural gas, that's good as long as the gas is pumping. But solar and batteries is just going to keep working because the batteries will charge up every day when it's sunny. Let's look at the next most recent, most severe example, Hurricane Maria in Puerto Rico. It basically wiped out the entire grid on the whole island of Puerto Rico. The power plants were mostly intact, but the transmission lines, those wires that go from the power plants out, they were wiped out. The local distribution lines were also wiped out. Trees were destroyed, knocking down the utility lines all around the island. The coal and the coal plants, I don't know if there's a nuclear plant in Puerto Rico, but the coal plants, if they have them, they were also shut down. And the natural gas plants, they're shut down because there was no place for the power to go. So, and I bet a lot of people had generators. It's smart to have a generator, right? But after a week or so, there's not going to be any more gasoline for the generators. People couldn't even drive on the roads because the roads were kind of covered with trees. So anybody who was relying on gas for generators or diesel for generators, you kind of run it for a few days. You don't think it's going to go that long. These people might be without power for a month. But once again, the people with rooftop solar and battery backup systems, although these systems are generally pretty small, they're probably, they have power. And the people in California that are putting in these systems now, if there's some kind of disaster here, they'll have power. All right. Now let's kind of look even more locally here in the United States or even in Silicon Valley. Local blackouts, much more common than they were before. We're not having failures of the entire grid. The natural gas plants that are powering us here in California, they're really solid. They're working great. The wind turbines that are, in lots of places around California, the solar power plants, they're just cranking out power. But when there's really bad weather, this actually happened at my house in February. Really bad weather in a storm. Trees got knocked down the power lines in our neighborhood. There was no power for 4 days because the power lines got knocked down. And a lot of other people's power lines got down too. So the utility was really busy trying to fix it. And it took them 4 days to get power back. Also, what happened twice. The distribution system, those transformers that are on the utility poles around the streets, they're overwhelmed because so many people have electric vehicles and air conditioning and they're using more electricity. There's just too much demand and the utilities aren't keeping up with that. Now, the centralized power from natural gas and solar and wind that are on utility scale, that's still working okay, but the power can't get to where it's needed. It can't get to the businesses. It's not getting to the homes because the local distribution systems that's getting knocked out. And that's probably the biggest problem in Puerto Rico right now. It's going to take them months to restore that entire local distribution system. But companies and people that have rooftop solar and battery backup, they still have power. In these short little blackouts, a generator is going to work great. If it's a long-term blackout or a really big disaster, there's not going to be any power. If there's another earthquake, and it'll happen, God forbid, there's not going to be natural gas because there's going to be broken gas lines, and the gas company is going to shut those, stop pressurizing those lines. So people who have a natural gas backup generator, which is probably the smartest way to go, although it's very expensive, but it's not going to be that reliable if there's a really big disaster. Only solar and battery backup is really going to work unless you decide to have 1,000 gallons of diesel fuel somewhere in a storage tank. Okay, so what's the solution for a more reliable grid? It's not more centralized. It's actually a myth that baseload generating power is needed for grid reliability. That concept's obsolete with distributed technologies and modern control systems. All right. So what does this new FERC rule mean for utilities? Well, the intention of the rule is to create a monetary incentive for utilities to keep coal and nuclear plants operating. Basically, the rule is going to instruct utilities to keep these plants going, even if they're not the least cost ways of generating power, even if they're polluting, because there's going to be a new incentive to talk about, hey, this is, supposedly more reliable, but we know it's not. And so utilities, they're not going to be decommissioning dirty coal and expensive nuclear power plants. And, this isn't really happening as much in California because there are no coal plants, and I think and the last nuclear plants are already being decommissioned. But in the rest of the country, this is going to give a reprieve, kind of a new lease on life, to a lot of these old polluting coal plants and a lot of these old nuclear plants. And it may also provide a little bit of a reprieve to new nuclear plants. There's actually now a $3.7 billion loan guarantee for the nuclear plant in Georgia that was not going to be built, but now the DOE is going to guarantee that. They're picking winners and losers. I'm not going to get into that compromise. All right. So we're going to see what happens. I think nuclear, if this rule goes into effect, is going to have a little bit of a reprieve, but it's not going to succeed. All right. So what does this mean for consumers? Well, it's going to have two direct impacts on consumers of electricity, businesses and homeowners. First, electricity is going to be more expensive because we're going to be subsidizing coal and nuclear, which is more expensive than wind and solar and storage. And not to mention the fact that there's going to be more pollution. The second impact is we're not going to be doing what we need to do to make the grid more reliable. We're solving the wrong problem. The problem isn't that we don't have enough coal and nuclear plants. The problem is that a distributed grid is inherently more efficient. So we're not solving those transmission and distribution problems. So what's going to happen next? The Department of Energy wants to impose these rules on FERC. Now, the FERC's an independent agency, and they're supposed to be listening to all of their stakeholders to actually improve the grid and create less expensive generating capacity, not imaginary things like supporting coal and nuclear. But the reality is it's very likely that FERC is going to be doing what the Department of Energy wants. What's kind of amazing is that the American Petroleum Institute, they make oil and gas, the Solar Energy Industries Association, and the Electric Power Supply Organization, these are three organizations that are kind of really on the same page. They've all joined together in lobbying against these rules by the Department of Energy Secretary Perry. The reason why they're lobbying against them, and quite frankly, is because these supporting coal and nuclear isn't good for the oil and the gas industry. It's obviously not good for the solar industry, and it's not good for the utility industry because they're going to be more polluting, and the utilities probably say, hey, we can make more money if we're using natural gas, wind and solar. All right. So we're going to see what happens, and there's a lot going on also with this Department of Energy new loan guarantee for the power plant in Georgia. We'll talk about that in another show. That's all the time we have on this week's Energy Show. So thanks to all of our listeners for tuning in. And if you missed any of today's show, you can always go to our website at cinnamonsolar.com and listen to the podcasts.
So, you want to save the world with clean energy? Make money doing it? Confused about the economic and technical realities of residential and commercial solar, batteries, heat pumps, EVs? Want the real-world scoop on new energy technologies, not manufacturer hype? Then tune in to the weekly Energy Show, hosted by Barry Cinnamon. Insights from Barry's 40-plus years in the solar and energy industry will help you understand the future ways we'll generate and consume energy. And now, here's Barry.